Good day, guys. How are you doing? So this is a quick overview of some important facts and important points you have to know on non-metals for you to really do well in your UTME chemistry. So let's quickly get started. Number one, which of the following metals cannot replace hydrogen from water or steam? A. Sodium, B. Magnesium, C. Iron, D. Calcium, E. Copper. Now this has to do with the reactivity of the metals. So for you to be able to answer this question, you actually have to know your reactivity series or the electrochemical series. Let's quickly go through it so that although the answer here is copper, the answer is copper because from our understanding of the electrochemical series, we know that copper is below hydrogen and it is low. The reactivity is low for it to displace hydrogen from water, from any form of water, whether it is steam or cold water or hot water. You understand? So let's quickly check through it. So this is the metals reactivity series. Popular scientists, that's a mnemonic for you to remember. Popular scientists can make a zoo in the low humid country more satisfactorily good. And you can see what they mean: potassium, sodium, calcium. So reactivity decreases from top to bottom. So that means potassium is more reactive than sodium. Sodium is more reactive than calcium. You understand that now? So yeah. So how do these guys react with water? Now the first three members in the reactivity series, they react with cold water to actually liberate hydrogen. Now, worthy of note is the reaction of potassium and sodium with water because that is very violent. That reaction is very violent. However, the three of them, the first three members in this list, can actually react with cold water. Please note that cold water to liberate hydrogen. Now, the next four members cannot react with cold water. Instead, they react with steam. And you know what steam is? That's a gaseous form of water. That's definitely hot. Yeah, they react with steam to liberate hydrogen. And iron has to be noted. Iron, the normal form of iron cannot react with steam. It has to be red hot. That means the temperature must be high for iron to react with steam to actually liberate hydrogen. And these reactions are very simple to be shown on the screen and how these reactions happen. Yeah. So then after that, we have lead. Lead downward do not react with water in any form. Yeah, so you might be thinking of tin. Yeah, tin also normally do not even react with steam, but in very high temperature they can do that, but usually we don't really count them like that, you understand? So yeah, so these are the important ones you have to note: the ones that react with cold water and the ones that react with steam. Yeah, so and then you have to know that magnesium we actually react slowly with cold water, but it will react quickly with steam. That's already written here. So that means it can also react with hot water, definitely. So now this is actually gotten from a topic in chemistry that talks about the production of hydrogen. So hydrogen, other ways you can produce hydrogen, this is not part of the question now. It's actually reaction of these metals with dilute acids. Yeah, dilute acids like HCl, dilute HCl, dilute H2SO4. But usually we don't use dilute HNO3 on metals because the reaction between metals and acid will give you salt and hydrogen. You know, we're talking about production of hydrogen now. The reason why we don't use HNO3, dilute HNO3, is because dilute HNO3 itself is a very strong oxidizing agent. So usually it oxidizes the hydrogen, so it doesn't produce hydrogen. So that is why we don't really use it in the production of hydrogen. Although this same magnesium can react with dilute, only magnesium, that's the exception there, only magnesium can react with dilute HNO3 to produce hydrogen. Others won't actually do that. Yeah. So question 2, when carbon dioxide is bubbled into lime water, a white precipitate is formed. If the passage of the gas is continued, the precipitate disappears. The reason for this is, now I won't bother to read the options, but you can check the options yourself. The answer to this question is option C. Now this is very important. You know, the qualitative analysis of CO2, like the identification of CO2 in the lab, we use lime water. Lime water is CaOH2. Yeah, the solid version of lime water is what we call slaked lime. Of course you know that. So yeah, so other substance that can help us identify CO2 is alkali solutions like caustic soda, that's NaOH, or caustic potash, KOH. You understand? Those guys can also detect CO2. But now speaking of lime water, which is the commonest of them, yeah, when you bubble it, let me show you the reaction. Yeah, so when you bubble CO2 into lime water, as you can see here, you have a precipitate, that's the solid, CaCO3, calcium carbonate. So the mixture of calcium carbonate and water is actually it's like a suspension. So it will give you this milky suspension, milky, because CaCO3 is actually not soluble in water. So it will be give you this milky or chalky appearance. So but on further addition of the CO2, you will see that a soluble calcium hydrogen carbonate will be formed. So this guy is actually soluble. So the chalky appearance will disappear at that point. So that's what happens. So on further addition of the CO2, another soluble compound will be formed. So the milky or chalky appearance of the mixture of CaCO3 and water will disappear, because we have the formation of CaHCO3 too. You understand now? So that's how it works. So question 3, which of these compounds will not give an oxygen gas on heating? A, magnesium dioxide; B, hydrogen peroxide; zinc nitrate; sodium nitrate; ammonium nitrate. So I think it's wise to actually see how these guys decompose so you can know your answer. So this is the decomposition of the guys. So you see manganese dioxide, this is the composition. The oxidation number of manganese in this compound is actually 4. That's plus 4. Why in the product of the decomposition, you can see that the oxidation number actually decreases to plus 3. So this should not be a surprise, because you know that manganese is a transition metals, and one of the characteristics of transition metals is what is that they have multiple oxidation states. Except for this zinc guy. Yeah, that's one of the reasons why it is not really a true transition metal. That's another thing, that's another point for another topic here. So yeah, the composition of hydrogen peroxide, this is it. And then you also have to note that the decomposition of every metal nitrate that you find on your reactivity series, all of them, their decomposition will always produce oxygen. Now you have to understand, you have to take note of the decomposition of ammonium nitrate. Can you see what it produces? It gives you laughing gas. Laughing gas is N2O. That's nitrous oxide. Yeah, that's nitrogen 1 oxide there. Yeah, so and it also gives water. So there's no direct production of oxygen right here. So that is why E will be our answer. Please, you have to know that. And then in the production of oxygen, we have the decomposition of KClO3 can produce oxygen, but in both process we need MnO2, that is manganese dioxide, as a catalyst. Please, that's very important. You should note that. Also in the decomposition of hydrogen peroxide, H2O2. So the decomposition of all the nitrates on the reactivity series will be displayed on the screen here. So question 4 says, which of the following pair of gases will not react further with oxygen at a temperature between 30 degrees Celsius and 400 degrees Celsius? Now this is about your understanding of oxidation. Now you will check, how will you know the answer here now? You have to check through the options and look for the ones that have not attained their highest oxidation, the highest oxide. Yeah, let me put it that way. That have not reached their highest oxide. The answer to this question is actually option C, because this is the highest oxide of nitrogen and sulfur. These are the highest oxide of nitrogen and sulfur. So if I add oxygen to NO2, it's not getting higher again, because that's the highest oxide. If I add oxygen to SO3, SO3 is the highest neutral oxide of sulfur. So there is no oxidation that wants to happen with them again. But if I add oxygen to SO2, it can become oxidized to SO3. So you cannot further add oxygen to oxides that cannot be oxidized higher, because they are already at the highest level of oxidation there. You understand? So that is how that works. So the answer is C, option C, NO2 and SO3. So question 5, some products of destructive distillation of coal are, so what is coal? Coal is basically an organic, let me say, is a black organic rock here that is formed as a result of the decomposition or microbial decomposition of vegetations and plant forms that have existed millions of years back. They call those time Carboniferous period. Yeah. So it's as a result of the decomposition, those plant forms that have been buried in the ground. So due to high pressure, high temperature over millions of years, so they form coal. So coal is actually black organic rock, yeah, if you call it that. So what is destructive distillation? Destructive distillation is basically the eating, decomposition of a particular substance in the absence of air or oxygen. So the answer to this question, to cut the long story short, is actually D. Let me show you. So here it is. So the destructive distillation of coal, we give you coke, ammoniacal liquor, coal tar, coal gas. Those are the four products you get there. So the destructive distillation of wood too, because wood too can undergo destructive distillation. So the product of the destructive distillation of wood is wood. They are wood charcoal, pyroligneous acid, wood tar, and wood gas. So let me just give this quick fun fact. You might be thinking of ammoniacal liquor. Yeah, ammoniacal liquor is actually used to make fertilizers. Yeah, and also this is where they get ammonia from formally before the herbal process started. So they actually find a way of getting ammonia from ammoniacal liquor before the herbal process, where you have to add hydrogen, nitrogen in presence of finely divided ion to produce your ammonia, which is what they do now. You understand? So that is how those ones work. Please, I hope this video is helpful, so you can use that to revise your non-metals. You can also read more because there are other things you still have to learn. You still have to revise on non-metals. So if you find this video helpful, don't forget to like, share, and also subscribe to my channel. See you in my next video. Bye.